As always, welcome to the review video for Shaughnessy's class. This is Rational Expressions Lesson 6. Standard disclaimer, please make sure you attend class. If you want, pause it, read it. Otherwise, I'm going to get going. This lesson is all about the product and quotient of rational expressions. We're multiplying or dividing rational expressions. It's the same rules as fractions. We just got to make sure that we're careful with them. Also, too, there is factoring because we do have to simplify after all is said and done. So you have those going on. Now, product of rational expressions, just like in fractions, you multiply the numerators together, then you multiply the denominators together, then once you're done, reduce what's left. Don't multiply it out necessarily because you're going to want to have to factor it down anyway in order to finish it off. So don't make a point of multiplying the whole thing out, like foiling it out if you like that acronym. Don't worry about doing that. Just keep it cleaned up as much as you can. So this is fairly simple. E.g., if I have, for example, negative 6x over 35 times, I'm using the dot for multiply, 14x over 3, okay, I look at this and say, well, what do? Well, I'm going to multiply the numerators together. So negative 6 times 14 is going to be, I think it's negative 84. There's an x times an x, which is going to be x squared. And in the bottom, I get 35 times 3, which is 105. Okay, so I end up with that. Now I'm looking, what can I reduce? What can I multiply by? One's even, one's odd, so 2's not going to work. I'm looking for a few other things. I see 3, so I'm going to say it's 3 times negative, and 84 divided by 3 is 26, I think. Whoops, going to my handy dandy calculator. 84 divided by 3, negative 28, sorry. X squared, and in the bottom I have 3 times 105, or 105 divided by 3, and it's going to be 3 times 35. So I look, well, 3's can cancel, so I'm all set and good. Keeping going, I notice another 7, so I'm going to say it's 7 times negative 4 x squared over 7 times 5. The 7's cancel, okay, and so I'm going to get negative 4x squared over 5. And that's what the product is. Okay, keeping in mind I always look for non-permissible values. Now with a product, I look here, 35 can't equal 0, but there's no issue there because it doesn't. And 3 does not equal 0, which it doesn't, so there are no NPVs. Okay, so I don't have to worry about that. There's no x's in the denominator. As I go through and I look at more complicated ones, it's the same basic idea all the way through. Okay, I've got example 4x minus 12 over x plus 1 times 4 over x plus 1. Okay, so I look at this. Okay, so those are going to multiply together. So I'm going to get 4 times 4x minus 12 over x plus 1 times x plus 1, which ends up being x plus 1 squared. Okay, so look at that. Has it been completely factored? I take a look. There's a common factor of 4 here. Whoops. I'm right down at the bottom, so I hope that's clear. Okay, so 4 times this, x plus 1 times x plus 1 is x plus 1 squared. Sorry about that. Here there's a common factor of 4. Pull that out. It's going to be 4 times x minus 3 over x plus 1 squared. Anything common? No. So I'm going to clean that up a little bit. It's 16 times x minus 3 over x plus 1 squared. I look at this and I say, what are the non-permissible values? Out of here, I know that x plus 1 cannot equal 0, so x cannot equal negative 1. And from this one here, I'm just putting an arrow there because it's exactly the same. So the non-permissible values are negative 1. So I've got that. Okay, I can go through and look at all sorts of different things. Okay, whoops. I can go through and look at more examples and just kind of play with this, you know. As I go through, it could get a little bit more complicated. I could end up with something like this. So e.g., and I've got 12x squared over 5x plus 20 times 10x plus 40 over 3x. Okay, with this one here. Okay, so I look at those and say, okay, I can multiply that. So really that's just going to become 12x squared times 10x plus 40 all over 5x plus 20 times 3x. And I'm going to make sure I've factored all these things. So the 12x squared, the 3x there, for the most part I can make this 3 times 4, and I'm going to. So it's going to be 3 times 4 x squared. In the bottom I've got the 3x. Now with the rest of it I'm going to keep going. In here there's a 10 common, so I'm going to pull it out. It's going to be 10, and it's going to be x plus 4. Here there's a 5 common, so I'm going to pull it out, and it's going to be 5 times x plus 4. And I'm looking for things that cancel. Well, here there's a 3 that cancels. Here there's an x plus 4 that cancels. So cleaning it up, I'm going to have 4 times 10 times x squared in the top. In the bottom I'm going to have x times 5, or 5x. And I say, okay, is that as completely factored as it can be? Well, 10 can be broken down to 5 times 2, and probably you saw this already, times x squared over 5 times x. The 5's will cancel as well. What it leaves me with the top is 4 times 2, or 8x squared over x. There's what I get. Now I still have to take a look at my non-permissible values, so I go out of here and I say 5x plus 20 cannot equal 0. So 5x cannot equal negative 20. So divide by 5. X cannot equal negative 4. There's one of my non-permissible values. Notice that it disappears. By the time I get to here, it's not negative 4 anymore. I don't have that one. It canceled out, but it's still an NPV. The other NPV is hiding here. It tells me that 3x cannot equal 0. Divide by 3, so x cannot equal 0. There's my other non-permissible value. That one has stayed. This one has canceled out. That's okay. That's what I've got. Okay. Now, continuing off with multiplying with slightly more weird ones, you get 3x squared y over 12xy times 8x to the 5th y to the 4th over 6xy squared. I look at this one. Okay, this one here I just multiply. Okay. I'm going to multiply the numbers, put the x's together. I'm going to do it a slightly different way, so I'm going to end up with 3 times 8. There's 2 x's here. There's 5 x's on this side. 3, 4, 5. So 7 in total. Here there was 1 y. Here there was 4 more y's. 1, 2, 3, 4. So I end up with that. In the denominator, I end up with 12 times 6. I'll deal with the numbers in a sec. Here there was an x. There was an x. Here there was a y. There were 2 more y's. So I put that in. Now I'm trying to clean this up. There's an x common. There's a second x common. There's a y common. Second y common. Third y common. So I end up with that. What I end up with is a 3 times an 8. There's 1, 2, 3, 4, 5 x's, so x to the 5th, and 2 y's, y squared, over 12 times 6. Now you didn't have to leave the numbers till now, but I wanted to focus on the x's. Now I'm looking at the numbers, and I've got 3, 8 is 2 times 4. In the denominator I've got 12, which is 3 times 4, and the 6, which is 2 times 3, and I've still got the x to the 5th y squared there. So looking at what else is common, the 3's common, the 2's common, the 4's common. Leaves me with a 3 in the denominator, so I end up with x to the 5th y squared all over 3. That's the simplified form of this. Looking at non-permissible values, 12xy cannot equal 0. That tells me that x cannot equal 0. Tells me y cannot equal 0. Okay. Same out of here, x cannot equal 0, y cannot equal 0. So those are my non-permissible values. That's multiplying rational expressions. All that it happens is that the algebra gets more complicated. Okay. So as you go through there, that's multiplying. Dividing is a slightly different situation, really not a lot different. You know that with fractions you multiply by the reciprocal. Okay? That doesn't change here. You just multiply by the reciprocal. The key thing to keep in mind is with the quotient, the non-permissible values you end up creating a second one sometimes. So you got to watch for that. So if I look at this one here, e.g., okay, 15x over 2x plus 6 divided by 10x over 3x plus 9. Okay, I look at this, and the first thing I say is, well, it's going to be a multiplication by a reciprocal. So all is well and good. It's going to be 15x over 2x plus 6 times 3x plus 9 all over 10x. So you think, oh, this is good. Oops, 10x. Okay. So then I'm going to clean that up, and it's going to be 15x times 3x plus 9. Now I see there's a common factor of 3, so I'm going to skip a step. Times 3x plus 3. So I'm going to factor it out as I go. Okay. In the denominator I'm going to have 10x and times 2x plus 6. I see the common factor of 2, so I'm going to pull it out, and it's going to leave me with x plus 3. Here I can see the x plus 3's cancelling out. Okay. I may even notice the 15 and the 10 becomes 3 halves. This is 5 times 3, this is 5 times 2, the 5's cancel. So I'm going to kind of do that. This becomes 3 times x times 3 because I cancelled out the 5. That's 3, that's 2. If you like this, please feel free to do that. Okay. In the denominator, I am going to end up with 2 times x times 2, 2 times x times 2. Looking there, I say, hey, wait, now that I'm looking at this again, because as you clean things up, you notice there's an x common, so I'm going to get rid of that. And when all is said and done, I'm going to get 9, 3 times 3, over 4. So all this is telling me is it doesn't matter what value of x I put in here, I'm going to get 9 quarters, 2.25. Doesn't matter. Negative a billion to a billion. The only thing is I have to keep in mind non-permissible values. So I look over here. 2x plus 6 can't equal 0. So 2x cannot equal negative 6. So x cannot equal negative 3. There's one non-permissible value. Looking over here, okay, 3x plus 9 cannot equal 0. So 3x cannot equal negative 9. Okay, divide by 3. X cannot equal negative 3. Same as before. I'm not even going to circle it because it's the same as before. And you think, okay, so my non-permissible values are negative 3. But that's not true. Because as I go through my work when I'm doing the division, I also end up with this denominator here, 10x. When I divide by the reciprocal, the numerator of the second fraction becomes a denominator. And since it becomes a denominator, at that moment, 10x can't be 0 either. The non-permissible values don't disappear, you just end up having another one. So I get, and I'm just going to move this over so hopefully you can see it, 10x can't equal 0. Divide by 10, so x cannot equal 0. So there are two NPVs, negative 3 and 0. The 0 isn't immediately apparent. When it comes to dividing by rational expressions, you've just got to keep that in mind, that often if there's an x in the numerator of the second fraction, then you may end up with a completely different non-permissible value, and you've got to be watching for that. So when you're dividing by rational expressions, you've got to check that non-permissible value. That's what this is trying to say. A key thing to keep in mind is with rational expressions division, non-permissible values are a bit trickier since there often may be additional non-permissible values to consider. See below. Notice this. That's the additional non-permissible value. Now I could go through and do a whole bunch more examples, and I do in class. Okay, so I hope that makes sense. I'm going to leave it at that for now. So that's lesson 6, and all you end up doing is you just keep going, and more the algebra gets more complicated. So good luck with the homework. If you have any questions, let me know, and see you next class. Thank you.